Hello everyone, my name is Hari, and this series of videos will be taking you through the YSP 5th grade spring lesson plans, this being the first video in that series. Before I go any further, I just wanted to get a couple things out of the way. This video is meant to supplement your prep, meaning that you should have read the lesson plan beforehand thoroughly, and you should be looking into your bags to make sure you have all the materials that are listed here, as well as anything else that you think would enhance your lesson or allow you to present it to the students as best as you can. Let's get started. Again, this lesson is endothermic and exothermic reactions. Looking at the materials lists, nothing seems to stand out to me except for the thermometer right here. It's important to take a couple minutes during your prep time, wherever that may be, to test your thermometers to make sure they can read both higher temperatures and lower temperatures. So just fill a cup with hot and cold water and make sure putting the thermometer in both actually gives you a reading that changes to become warmer, to become cooler. It's important that you do this because it would not be fun for the students to get a thermometer that doesn't work properly and they won't be able to understand their data, and they might not get the best understanding of the science that we're learning that day. Going forward, let's look at the engagement and the review that we should do from previous lessons. This lesson is especially a little bit weird just because the 5th grade curriculum of the fall does a lot of chemistry, I think, in the last 3 or 4 weeks of the semester. And this experiment right here, endothermic and exothermic reactions, is still clearly chemistry, but it's kind of like the tail end of that whole unit, which means that a lot of the stuff that they learned in the fall in the last couple weeks of teaching way back in November or early December might not still be in their heads right now. So it's especially important to do a little bit of extra review this week that you might not have to do in other weeks. The reasoning behind that is because they did do a lesson on chemical reactions already. This is the comment that I left here. It was a lesson with baking soda and vinegar being used to create carbon dioxide and inflate a balloon, but because that was so long ago, the concept of a chemical reaction and chemical changes and physical changes might still be important concepts to discuss before getting started or moving forward with this lesson. The only new content covered here is talking about whether reactions are endothermic and exothermic, obviously, and correlating those to whether or not they increase and decrease in energy, and what that means about increases or decreases in temperature as well. Looking at the exploration section, this can also become quite complicated if you aren't prepared going into your lesson. I understand that each class has a different way of passing out supplies that works best, whether it be doing all of your supplies at once, or doing it as you go to do before each trial, or getting some help from students to help you pass out supplies. Whatever works for your class, go with that, as long as you can get the message across and finish the lesson in the appropriate amount of time. It's still important to have the student worksheets, the endothermic and exothermic reaction worksheets. It should look something like this, passed out at the beginning of the lesson, because that's going to be important for all the trials they do. Now, as for passing out the supplies throughout the experiment, there are a couple ways you can do it. Again, I said you could pass out all 8 of these materials all at once. I don't know if I would recommend that because there's not really a place to store the 4 different powders they're using while they're doing the other trials, and stuff could get mixed up. If you get some extra cups from the JEP house and label them or something like that, I'm sure you could find a way around that. But the way that I found to work is that we pass out the first set of materials first. While they're doing that experiment, start passing out the next one. While they're doing that, start passing out the next one. That way the students are never idle, they're always working on something, and then you can always be pumping out new materials for them to work with, so then they don't get off task either. Now, that does come with one complication, and that's right here, for the waiting 2 minutes to record the final temperature of the solution. Yes, as scientists, we know that we want to minimize as many variables as possible so we can best understand our scientific results, but that might not be as practical here if you are passing out the materials in a staggered fashion going from group to group, because that means the students might not be starting their experiments at the same time, and thus might not reach the 2-minute mark at the same time. What you can kind of do to combat this is estimate when those 2 minutes would be, because regardless of how long it takes, if it's an endothermic reaction or an exothermic reaction, it should still result in the change in temperature that you're looking for. That's what I ended up doing in my class, and it worked fine. Again, we didn't have a strict timer for the 2 minutes. We just estimated when approximately that would be and took the final temperature and had them write it down in their on their worksheets. The last thing in the exploration section is talking about this bullet point number 6. I left a comment right here on the right side. It could be whether or not your students are either have time to finish doing the subtraction calculations for that, or if you don't know if they're comfortable doing the subtraction calculations for that. It might just be in your best interest to have them consider, did the temperature go up or down, rather than actually doing the math, and then using that to lead towards the discussion of whether or not each reaction was endothermic or exothermic. The last thing to consider is after each trial, make sure they are recording their data in the scientific or in the worksheet that you get, which is starting temperature, observations, final temperature, and maybe at the end of your lesson you can debrief and go through all of the endothermic, exothermic, and this final column at once. Looking at this explanation section, just looking at these bullet points right here, the endothermic reactions are the water and Epsom salt and water and new salt. And from my experience, these don't produce as big of a reaction, like as big of a change in temperature, because again, it's just the salt dissolving. It's not as big of a deal as vinegar and baking soda or hydrogen peroxide and yeast. But I think in my class, they still produced a slight bit of change, and you might find the same stuff. Again, if you want to test it out beforehand, feel free to do these experiments in your own, wherever you live, to make sure you're getting the desired results, or see if there's anything you need to change for your lesson to make sure that your students will be getting the desired results. Looking at this, graphing your results also might be difficult given the time constraint or given any other constraints of your classroom, so that could be something that you might not have to, or you might not want to incorporate into your lesson as well. The law of conservation of energy, this is the last thing I want to talk about for this lesson, because it does come into the next lesson as well. A preview for next week, they're going to be making roller coasters out of pipe insulation, and that's a big deal with conservation of energy. So if you do have a chance to plant this seed in their head for next week so they can keep that in their head, maybe retain it, maybe it'll help their understanding next week, it would be a good idea, and I would recommend somehow trying to incorporate the law of conservation of energy into this experiment. Again, everything in elaboration and evaluation are pretty self-explanatory. Again, if you have any questions, feel free to ask any of the veteran TAs who have taught these lessons before. And with that, I will see you next week for some roller coasters.